Hello everyone, this is in continuation of our videos in which we are solving the questions from the pre-RMO 2018 question paper. So today our focus will be on question number 3 from the very paper. So in question number 3 it has been said that we need to consider all 6-digit numbers of the form ABCCBA where B is odd. And we need to determine the number of all such 6-digit numbers that are divisible by 7. So the conditions which are applicable on ABCCBA is that B is odd and also these numbers ABCCBA are divisible by 7. So if we have a 6-digit number of the form ABCCBA, so this is the number. So if this number is divisible by 7, so that means then the criteria for this number to be divisible by 7 is that the number ABC minus the number CBA must be divisible by 7. So this is a structure. So what is ABC basically? So ABC is basically we have 100A plus we'll have 10B and then we'll have C minus 100C plus 10B plus A. So this must be divisible by 7. So that implies that we'll have 99, B will cancel out, 99 A minus C. So this number must be divisible by 7. So if this number is divisible by 7, we can write 99 into A minus C as something. We can write it as 7K. Suppose 7 into some number K, where K must be a natural number. Okay, so this is the structure. Not a natural number, K can be any integer. We can say K belongs to the set of integers, we can say. Okay. This is what we know. Now 99 is not divisible by 7. Now 99 is not divisible by 7. Not divisible by 7. So that means A minus C must be divisible by 7. So we can also write that A minus C will be divisible by 7. This is the structure that we are ultimately trying to get. So now A and C are basically digits. So the possible combinations for A and C are, we can have either if we have A equal to suppose 9, then C must be equal to 9 minus C must be divisible by 7. So we'll have either, we can have 2. So 9 minus 2 will be 7 and that is divisible by 7. So if we have 9 2, then we can also have 2 9, since the reverse will be also true. And then we can have A equal to 8 and C equal to 1. In that case also 8 minus 1 will be 7, this is true. So 1 minus 8 or basically 1 comma 8 is also a pair that is possible. And then we can have 7 comma 0 and similarly 0 comma 7 is the same thing. And then we can also have, since 7 also divides 0, so we can have numbers of the format 9 comma 9, then 8 comma 8, 7 comma 7, 6 comma 6, 5 comma 5, 4 comma 4, and that can go on up till we have 3 comma 3, 2 comma 2, 1 comma 1. We can have 1 comma 1 also, but we cannot have 0. We cannot we cannot have 0 comma 0. Okay, so why we cannot have 0 comma 0? Because if we have 0 comma 0, so that means that it will no longer be, if we put A equal to 0, it is no longer a 7-digit number, it is a 6-digit number, it is a 5-digit number. Similarly, if we put C equal to thing, so in this case where we assume that AC can take the format of 0 comma 7, this is wrong. This is not possible. See. So basically, let me rub it out. This is the mistake that I committed. So let me rub it out. So we now have the basically the possible pairs of AC. So how many pairs are possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have, basically we can say that we have 14 pairs of A comma C. Now B is an odd number. It has been said that B is an odd number. So B can basically take the numbers 1, 3, 5, 7 and 9. So we have 5 options. 5 options for B. So therefore ABC can take the, so we have 14 pairs for AC and 5 options for B. So therefore total number of possible cases as required will be equal to, we have 14 cases for AC and 5 cases for B. So total number of cases will be 70, which is the correct answer. This is how you solve this question. Number 3 from the pre-RMO question paper which came in 2018. We'll be solving the next questions in the subsequent videos. Thank you very much.